Could Proxima b be another Earth-like planet? These are speculations everyone keeps making. The search for an alternative habitable planet and alien life on other planets is something that humans are fascinated with. There have been various speculations, and the fact that there have been signals coming from Proxima b makes people believe there is more to it. Despite all these signs, we have yet to determine if these are messages from the planet or just echoes of our own scientists' signals. Often, these signals end up as echoes. In finding out whether these signals are truly from Proxima b, scientists hope to determine if alien life exists. Recently, the James Webb Telescope detected artificial lights on Proxima b. If you're interested in learning about other planets and our progress in finding alternate life, subscribe to our channel. We make content about outer space and talk about innovations in science. If you like this content, comment below and share this video with your friends. Now, let's go back into our video. Proxima Centauri, about 4.2 light-years from our solar system, is a faint dwarf star classified as GZV. Thus, the star is known as Proxima Centauri. It is the closest star to our Sun and solar system, named Alpha Centauri by Johann Bayer in 1603. The name came from the star's ascension at noon while several celestial bodies, like the Moon and the Sun, were in a straight line. Proxima Centauri is also known as Alpha Centauri C or Alpha Centauri A. It is a single star system with 4 named stars in a line. Proxima Centauri is at the center of this system. Apart from the 4 stars, there are 2 faint dwarfs, Alpha Centauri A, also called Rigil Kentaurus, and Alpha Centauri B. These make up the bulk of the mass but are too faint to be seen by the naked eye. The system is located 23 degrees away from the border of the famous Plough asterism in the constellation of Centaurus. Even though Proxima b is a rocky planet, there is still hope that it might have extraterrestrial life. The search for any other life out there has brought scientists to Proxima b. They believe the similarities to Earth's size and its distance from its dwarf star make it a viable option for planets that can accommodate life. While all these are speculations, there's hope there might be some truth. There is much to learn about Proxima b and the orbit it takes, so stay tuned and find out. You can also check out some of our other content related to extraterrestrials. Do you really believe there's another life out there? Leave a comment down below. What fascinates most people about Proxima b is its similarity to Earth. Studies show that Proxima b is an exoplanet that orbits an M-type star. Its mass is considered to be 1.27 times that of Earth. Besides, Proxima b takes 11.5 days to complete an orbit of its star. It was discovered in 2016, and many scientists are looking into it. Even though Proxima b looks similar to Earth, certain features make it uninhabitable. For one, the planet is too close to its star, which results in extreme ultraviolet radiation from the star. It is estimated to be hundreds of times more than the radiation we get from the Sun. This radiation is so strong that it strips away even the lightest hydrogen molecules, and over time it does the same to oxygen and nitrogen. While most people might argue that Proxima b should be habitable because it is at a similar distance from its star as Earth is from the Sun, there is more to it than meets the eye. Distance does not account for whether there is water on the planet, and there is also no evidence of an atmosphere conducive to living things. The atmosphere on Earth is what makes it habitable, unlike Mars. The right atmosphere allows for climate regulation and a water-friendly surface. It also shields living organisms from hazardous space weather. If you're with us so far and have not subscribed yet, take a second to hit the subscribe button. It makes it easier for us to keep creating content like this that you'll love. Now, let's look at why people think that the James Webb Telescope will help us figure out if there is life on Proxima b. The James Webb Telescope was launched in 2021 after being delayed since 2011. Many changes had to be made to ensure it gave accurate images. During production, Loeb explained that if a planet like Proxima b could absorb light from its star, it could also emit it as infrared light. The James Webb Telescope was explicitly invented to observe infrared light. It can take photos of this light on the surface of a planet and look for patterns that might confirm if the planet has water or an atmosphere. One reason why space telescopes are preferred over ground-based ones is that, being above the atmosphere, they don't have to peer through the shifting air to see deep into space. Therefore, they get a better view of what goes on outside the solar system than most ground telescopes can achieve. The other advantage is that weather changes on Earth do not affect them, allowing astronomers to ensure they're getting a clear reading. The only downside to having a space telescope is that fixing it is expensive if something goes wrong. There have been cases where a small flaw in a space telescope required a whole mission into space to fix it. Such costs make observing planets like Proxima be difficult. With the James Webb Telescope, there is no option for rescue. It has been launched over 1.5 million kilometers away, further than any human has ever traveled, so rescue missions are not an option. The James Webb Telescope comes with a larger mirror, which allows us to see back to the beginning of the universe, almost 13.7 billion years ago. The further away an object is, the further back in time we get to see it, because it takes a while for the light to travel from an object back to us. The ability of the James Webb Space Telescope to see the universe in longer wavelengths, in infrared light, means we can observe more distant galaxies in our universe with more certainty than was previously possible. Therefore, observing planets like Proxima b has become easier, and it has pushed the light out of the visible range and into the infrared. Tabor and Loeb have proposed a scale of artificial illumination as a fraction of how the sun illuminates and reflects on the day side of the planet. At 0% on the scale, one would assume that the planet's night side is completely dark, while at 100%, it means the planet's night side is just as bright as the day side. There has been a hypothetical civilization on Proxima b using this type of light, and most scientists believe it is similar to the early days on Earth. Studies show that if the night side of Proxima b reaches an illumination of 5% of the natural day side, the James Webb Telescope could detect the artificial light by 85%. If the illumination reached 9%, the telescope would detect up to 95%. Even though 5% illumination sounds like a small number, we're talking about the light from a star as far as Proxima Centauri compared to our Sun. We have an illumination that is 20,000 times dimmer, yet we still have a lot of light from our star. This basically means that at 0.1% illumination, we are still reflected in the stellar illumination. In other words, if Proxima b has any civilization that glows like Earth, the James Webb Telescope would not detect it. The stars would need to be about 500 times brighter. This scenario is impossible since Proxima b orbits so closely to its host star. There is a chance that it might be tidally locked, meaning one side of the planet always faces the star while the other is in perpetual night. A civilization living on a tidally locked planet might need to focus on illuminating infrastructure and use very bright orbital mirrors to reflect sunlight from the day side to the night side of the planet. All these are speculations made by Tabor and Loeb, and there is yet to be proof to show that it is true. The Earth's illumination can be seen from outer space and is known as airglow. Most people wonder why the world is surrounded by bright shades of red, yellow, green, and purple light when viewed from 300 miles above its surface. The airglow happens when atoms and molecules in the upper atmosphere produce light to release excess energy. On Earth, airglow can happen when atoms and molecules get ionized by sunlight and capture free electrons. The glow seems similar to an aurora, except that auroras are driven by high-energy particles from the solar wind. The airglow is driven daily by solar radiation. Since the James Webb Telescope's launch, scientists have been asking whether it is sufficient to view other planets in faraway galaxies. Even though it is the furthest satellite telescope launched, it still provides very little data needed to find planets with life in other galaxies. As such, there have been conversations about developing bigger and better telescopes. These ventures are often costly and involve a lot of trial and error. The James Webb Space Telescope's launch was 7 years late due to these issues. Therefore, it is challenging for most scientists to develop better innovations that can be launched further into space. Despite this, the James Webb Space Telescope results are promising. Soon, we might know if there is life on Proxima b and other planets. While work is still being done on more telescopes, it is believed that the completion and launch of the Habitable Exoplanet Observatory, HabEx, will revolutionize space study. The estimated completion time of HabEx is 2035, with a launch soon after. HabEx will be sensitive to all planets in the universe, although its main objective is to search for Earth-like planets. Its advanced technology will enable it to measure the spectra of most planets and determine if they are habitable. HabEx is also believed to have a broad range of astrophysical capabilities. This feature will enable HabEx to study the earliest possible times in the universe's history, gather information, and understand the life cycles and deaths of massive stars, as well as the elements that support life as we know it. Even though HabEx is still in manufacturing, the technology used to create it will allow it to study Earth-like planets at such excellent resolution that the images from these planets will be incredibly clear. HabEx will be sensitive to ultraviolet, near-infrared, and optical photos. The concept behind HabEx is quite compelling and will change space study as we know it. If it can be pulled off, space study will indeed change. People can look forward to more information on extraterrestrial life on other planets. It also provides a better picture of Earth, as it can look back many more years before the civilization of the world and the changes that have happened with our climate. Lewis's idea is a smaller version of a telescope, but still builds on our experience with the James Webb Space Telescope. It has ultraviolet capabilities and is considered the next observatory telescope to be used by most astronomers. Astronomers plan on launching LUVOIR simultaneously with HabEx. The large UV/optical Earth surveyor will greatly enhance space study. Test studies done with LUVOIR show that it will be able to understand what makes Earth stand out from the rest. Several observations have been made of 28 Earth-like planets, and the results have been promising. With such telescopes in manufacturing, details about planets like Proxima b can be clearer. Even though the James Webb Space Telescope has made great strides in discovering new details about Proxima b, there is still much to be done. Better visibility of other planets and the ability to look at atmospheres differently are required to help answer the question of whether there is extraterrestrial life. It also gives deep insight into the planet's history and looks at the changes that have happened over the years. Ever wonder what would happen if we discovered extraterrestrial life? Worry not. We have videos on our channel that talk about this and many more topics. Subscribe to our channel and hit the notification button to get notified whenever we post new content. Is there life outside of planet Earth? The conversation about life on other planets has been ongoing for a while now. Most people believe that we are not alone in the galaxy. There have been theories that have come up and claims that have been ascertained for years. Whether we get to know if we have life on other planets or not depends solely on the kind of research we carry out. For this reason, scientists are working to ensure that we have more space telescopes orbiting the Earth and other planets. However, they need to be more powerful and look beyond infrared lighting to give us better answers on different planetary life. For now, the quest continues. The exploration of Proxima b opens up exciting possibilities for our understanding of planetary systems and the potential for life beyond Earth. As one of the most studied exoplanets, it serves as a focal point for astronomers and astrobiologists alike. Proxima b resides in the habitable zone of its star, meaning it could theoretically support liquid water, an essential ingredient for life as we know it. Further investigations of Proxima b involve not just telescopic observations, but also theoretical modeling. Scientists use computer simulations to predict the planet's climate and atmospheric conditions based on its proximity to Proxima Centauri and its orbital characteristics. These models help scientists assess how stable its environment might be over geological timescales. Another fascinating aspect of Proxima b is its potential for tidal locking. If the planet is indeed tidally locked, one side would experience perpetual daylight, while the other would be in constant darkness. This unique feature could create stark differences in climate and habitability across the planet, potentially allowing for diverse ecosystems. Moreover, researchers are exploring the impact of stellar flares from Proxima Centauri on the atmosphere of Proxima b. These flares, which are common for red dwarf stars, could strip away the planet's atmosphere or significantly alter its chemical composition, making conditions even harsher for potential life forms. The advancements in technology, particularly with the James Webb Telescope and future missions like HabEx, offer the prospect of deeper insights into Proxima b's composition and atmosphere. For example, spectroscopy can identify specific molecules in the atmosphere that might indicate biological processes, such as oxygen or methane. In addition to Proxima b, the search for exoplanets continues to expand. Thousands of other potentially habitable planets have been discovered, each presenting unique characteristics and mysteries. The collective study of these worlds will enhance our understanding of where and how life might exist beyond Earth.